In this video, we're going to again try to evaluate do a hypothesis test. So we have, in this case, we're trying to test a golf club that's a 6-iron, and we're trying to determine whether or not it meets its specification. So the specification was that the ball needs to go 180 yards when the club hits the ball at 85 miles per hour. Okay, so the accuracy is very important here. So we want the club should be within plus or minus 5 yards of the of 180 yards. We're also given that the person who's evaluating the club will do 6 tests, and from those 6 tests, they found that the average was 182.7 yards, and the standard deviation from those 6 tests was 2.7. So, based off of that information, should the engineer who tested the club certify the club meets the specifications within 5% level of significance? Okay, so in order to do this, all right, we included all the information that we have from the prompt on the left. All right, so given all this information was given to us here, so we're going to just do the same steps we did for the continuous sampling that we had earlier, but now we're going to do it for a discrete sample. So we're going to use, instead of using the z-test, we're going to use the t-test. So the first thing we're going to do is similar. We're going to define our hypothesis, our null hypothesis, and our alternate hypothesis. So very simply, our null hypothesis is that the true average yards that the club can hit matches the desired average that the club will hit, so x prime will equal xo. All right, and our alternate hypothesis will state that that the true average of the club does not equal 180 degrees. Okay, so what we need to then do is set our rejection region. All right. So we're given, in this case, the level of significance. Okay, so in our case, we're given 0.05. So from that, we can calculate what is our t-value. Okay, so our t-value is we can find using the t-inverse function. So t dot inverse that 2t will give us a two-tailed inverse order distribution, and then it asks for a probability and degrees of freedom. So probability in the case of this function is not percent probability, it is level of significance. So make sure you put in the level of significance, not the probability. Okay, so we're going to put in 0.05 here, and then the degree of freedom is going to be 5. Right, so just 1 minus the number of samples that we took. Right, so we do that, we get a t-score of 2.57. All right, and then we can estimate the lower bound and the upper bound of our rejection region using the definition of the t term. So what we're going to do is we're going to take the mean value that we got. All right, we're going to subtract to find the lower bound the t-score times the standard deviation. All right. All right, and then to find the upper bound, we're going to do the opposite. So we're going to take the sorry, I did the wrong thing. It should be not the mean x bar value, it should be the x prime value. Sorry. All right, there we go. All right, now we're going to do x prime plus the t-score times the standard deviation of our measurement. Alright, so that gives us our lower bound of minus 173 and our upper bound of 187 approximately. Alright, so then we can calculate the t statistic t0. Alright, so the t statistic is really easy to calculate. We'll take the difference between our x bar and our desired average x, and we'll divide that by our standard deviation, or divide that by the number of tests, by the standard deviation, and then we'll divide that by the square root of the number of tests that we took. Alright. Alright, and that's just from this formula on the right hand side here. Alright, and then the last thing we can do is just check to see if t0 is less than t. Now, it's very obvious that t0 is less than t, but if you want to create an automatic spreadsheet where you just plug in a couple numbers, uh, and you can just change the numbers on like the inputs, and see if the hypothesis is true. You can make a nice if statement that would say if the t0 is less than t, then we can say that our null hypothesis is confirmed. And then if not, we can say it is rejected. Null hypothesis is rejected. Right. So in this case, we got a nice confirmation. Our null hypothesis is true. So the engineer can certify that the clubs or meet the 5% level of significance of hitting 180 yards based off of his experiment.